Hey guys, welcome back to bioinformatics, or computational biology, that is, with Python. In this video, what we're going to do is we're going to kind of rehash some of the ways that functions work in Python. So we'll write some simple examples, kind of look at a way to manipulate data over and over again, which functions and loops and things like that are great for, and have this building block for you in your tool set for continuing to learn and develop your Python skills. So let's go ahead and jump right into it. Okay, so first things first, let's open a Python notebook. Actually, let's close that. And remember, if you're doing this on Praxis, we need to go to desktop, classroom, my files. Now we want to create one. Or you can create it and then move it, save it later. So, all right. First things first, let's create a function to change Fahrenheit values, or between Fahrenheit values and Celsius values. So let's do Fahrenheit val equals 99. Then we're going to say Celsius val. This is good for us Americans that don't use Celsius. So you subtract 32 and then you multiply it by 5/9. All right, so let's run this code. Bonk. Perfect. So now let's do so we have to print Celsius val. You have to say it right. So print oh my gosh, there we go. There we go. So 99 degrees is 37.22 degrees. So you see this function works well because we save what our Fahrenheit value is, and then we say, okay, the Celsius value is the Fahrenheit minus 32 times 5/9. The problem is if we're going to do this over and over again, we can. So we can do Fahrenheit value 2 is, and we'll say it's 43 degrees this time. Then we'll say Celsius val 2 is equal to Fahrenheit val 2 minus 32 times 5/9, and then we'll print. We'll move it down line so it matches above. Print Celsius val 2. Oops, don't capitalize that. Val 2. So now we can run this. Say, oh, okay, so 43 degrees is really 6 degrees Celsius. But if we wanted to do this for, like, say we had like a big Excel spreadsheet and we want to convert all the Fahrenheit to Celsius, well, we could write a function. And this will make it so we don't have to keep either copy and paste or just rewrite these codes over and over again. So we can say def or define explicit Fahrenheit to Celsius, and for every temp that we are given, or temperature, we're going to annotate in here too. So we're going to assign the converted value to a variable, and we're going to say converted equals temp minus 32 times 5/9. So you can see that this is the conversion right here, where we say, all right, whatever temp that we're given, we called it Fahrenheit value up here. We're going to subtract 32 and then multiply by 5/9. And then we're going to say return the value of the new variable. So we're going to say return convert. Okay, so now we can save this. And we can also, we're going to do this another way. So we can, we'll call the second one far to Celsius. So we're not going to call it explicit. And we'll say temp. So for whatever temp we're given, we're going to annotate this. So we're going to return converted values more efficiently, using the return function without creating, and I'm going to go down and keep annotating, a new variable. This code does the same thing as the previous function, but it is more explicit in explaining how to return, or how the return command works. That's talking. I don't like the way this is written. Okay, so now we're going to say return, and we're going to say temp minus 32 times 5 divided by 9. So these two codes are the same thing, right? So it's two different ways to do it. So this says return. Let's do return. So in essence, it's just combining these two lines, right? This one up here shows explicitly what's happening. So we're going to create this variable called converted, and we're going to take the temp minus 32 times 5/9, and then return it, print it out. In the second one, we just combine those two, right? So we just return, and we didn't save it to a variable. We just said the temperature minus whatever. Okay. So let's try running our function. So let's do the second one. Fahrenheit, fair to Celsius, and we'll say, give it a number, 32. So we don't have to print out all that stuff or write that big long function. 0 degrees, right? So 3 degrees or 32 degrees in Fahrenheit is freezing, right? And 0 degrees in Celsius is freezing, so that's perfect. Let's try the same thing with the other one. So explicit Fahrenheit to Celsius. We'll say 32, and hopefully we have the exact same results, right? So they both work the same way, right? Just depends kind of on your preferences of how to do it. So we can also use that function inside other functions. So we'll say print freezing point of water. So print is its own function, and I'm going to say far to Celsius. I don't know why you do this. So just type it out. And then I'm going to say print boiling point of water. 202 is boiling point for water in Fahrenheit. Okay, so if you run these now, we have the freezing point of water is 0.0 Celsius, the boiling point of water is 100 Celsius. So you can see you can put this function that we defined into other functions and use it as well. Okay, let's do let's keep on with our temperature stuff here. So let's write another function to change Celsius to Kelvin. So def Celsius, or define, to Kelvin. So we'll say temp C for this. And we'll say return temp C plus 273.15. Then we're going to print freezing point of water in Kelvin. Celsius to Kelvin, so you can hit the tab cheat just like in R. I'm going to say 0 point. And let's run this. Temp C. First of all, freezing spelled wrong there. I see that. Temp C. Why is that defined? Okay. Oh, return. There we go. So the freezing point of water in Kelvin is 273.15. So now, what if we want to convert Fahrenheit to Kelvin? We can combine our two functions, right? So def, we'll say Fair to Kelvin. We'll say temp F for Fahrenheit. Then we say temp C is far to Celsius. Temp F, we say temp K, so Kelvin, is then taking that Celsius to Kelvin, temp C, which we just created, and then return temp K. Then we'll print the same thing. I'm just going to copy it, so I don't have to from right here. Let's paste it. It's probably took as long as it would have taken me to write it. And then we'll say to Kelvin 212. I'll put 0.0. Okay. So freezing point of water in Kelvin is, why is that off? What did I do? Oh, wait. This is because this should be boiling. Yeah, so boiling point of water in Kelvin is 373.15. Perfect. So this is kind of how larger programs are built. So we do basic operations or functions and then combine them in ever-growing chunks of code that start to build and do things that we want them to do. And so do we want to keep going? What are we at? 13 minutes? Okay. Let's keep going. All right, yeah, so that's how programs are built. So you build little functions and you can start combining them and use them as like building blocks instead of having to write them over and over and over again. Okay, so when we did our variable or our previous functions for temperature, we made variables inside of those functions such as temp C, temp K, temp F somewhere, I don't remember, it's somewhere up here, and then just temp. So we refer to those as local variables. So the reason that they're local variables is because as soon as the function is done executing, they get wiped away. So if we, for instance, if we try print again, temperature in Kelvin was temp K, So as you can see, temp K, even though we had it right somewhere up here. Anyways, since we defined it before, it no longer exists, right? So if we want to reuse, right here, this is where we defined it, right? So since it's within a function, it's not a permanent variable. So if we want to have it be permanent, it has to be outside of the function, right? So we can say temp Kelvin equals var to Kelvin 212.0, and then print temperature in Kelvin was, and then comma temp Kelvin. So if you run this, good to go. And then if we run temp Kelvin, I'm not going to redo it. You can see that it's permanently stored now. So because we defined it inside the function, it's not in our permanent environment. This is going to bug me, so I'm going to rerun this, and then I'm going to delete this, and I'm going to run this. Okay, there we go. Yeah, so since it's outside of a function, we call that a global variable. So in a function, you can read in global variables, right? So def print temperatures, print temperature in Fahrenheit was temp F AHR, I believe we called it, print temperature in Kelvin was temp Kelvin, and then we'll say temp FAR equals 212.0, temp Kelvin equals var to Kelvin, temp Kelvin, temp var, and print temperatures. All right, so let's run this one. So you see that we say temperature in Fahrenheit was 212, temperature in Kelvin was 315. So what this is doing is this is just pulling these values, right, because they're in the global environment. So we define them above, not in a function. And so whenever we use a function, we can then pull them back into the function. Or whenever we define them outside of the function, we can use them within the function. All right, 18 minutes. A pretty long section. Okay, I think that is what we're going to end on. Actually, before we get into that, make sure you file, save notebook as, stay desktop classroom my files. That's exactly where to be. I'm gonna call this one creating functions part 1. I'm gonna save it. And then I'm gonna go back to change my screen. Okay, so that is the end of part 1 of creating functions. I'm actually going to, we're going to continue on shortly with some tightening up and making reloadable functions and things of that nature. So I hope you enjoyed this video. If you're watching on YouTube, hit like, hit subscribe, and without being too long-winded, I'll catch you in the next video.